There we go. Can you see my screen and hear me all right? Everyone turned off their mics and cams.
Yes.
Excellent. Okay, well, thank you. Thanks for the introduction and for pairing with me through this Friedman Family Visiting Professionals Program. This is my first year doing it. I think we were scheduled to do this about a year ago last year when the sky was sort of falling, so to speak, and obviously had to get postponed. So I'm definitely disappointed that I didn't get the opportunity to go out and meet you all in person and hang out and, all the sort of supplemental activities of, grabbing coffee or beer afterwards and that kind of thing, because I was really looking forward to that. But at any rate, here we are, and I proposed a couple of ideas of some projects and topics I've been involved with in my, roughly 12-year career at Reed Middleton. And one of the topics that came up of interest was a bunch of the post-earthquake reconnaissance work that I've had the opportunity to do. And so today I'm going to really just give a high-level summary, which was a really interesting exercise for me personally to sort of reflect back on these various experiences that span for me about the first decade or so of my career and seeing earthquakes firsthand and kind of take a high-level view of what I remember, what have I taken away personally, and what are the lessons learned for a profession, and then just my experience as a consultant engineer and how that sort of fits into that. So if you aren't aware, Friedman Family Visiting Professionals Program is basically supported by this endowment that allows for travel. Of course, that didn't really work this year. So I first have a couple of slides on ERI that I was asked to share just to really acclimate everyone to the organization if you're not familiar. It's a global earthquake engineering institute and essentially a non-profit technical society, much like SCW, ASCE, all those. But I think the thing that makes it really unique and exciting for me is that it's really organized around a cause more than a discipline, if that makes sense, a profession. So it's really just a bunch of people dedicated to working various roles and capacities of reducing earthquake risk. And they work on that a number of ways. Of course, there's sort of a number of sort of technical ways in advancing the science and practice and providing tools and resources accordingly. There's a lot of research, as the name suggests, in understanding impacts of earthquakes. They have a really long-standing LFV program, Learning from Earthquakes program, that sort of relates to the reconnaissance work I'll be sharing about today, even though the reconnaissance I've done personally have been in different types of capacities, so to speak. And then the other thing is, advocating for realistic measures and really policies, and that really makes the organization feel like it's actionable and it's not just learning for the sake of the learning, but it's empowering and advocating of ways we can sort of contribute to reducing earthquake risk. And as I mentioned, it's a multidisciplinary organization, so there's certainly a high proportion of structural engineers and seismologists in the organization, but there's other disciplines and professions as well. As you can see, anything from emergency managers, social scientists, planners, business professionals as well that sort of are really interested in this topic. And I think that sort of more holistic perspective is really what makes it sort of valuable, and, particularly on the committee level, to sort of addressing these big, hairy, audacious goals that the organization has. And so for students, some of the benefits, if you're not familiar, obviously one is this program really intends to connect professionals, working professionals with students and bridge that gap, so to speak. I'm sure students online are also familiar with the Seismic design competitions, papers, fellowships that it has. I understand they have travel grants to ERM meetings to sort of supplement funding for that. There's an internship program, access to Spectra, et cetera. I imagine everyone here is part of the Notre Dame ERI chapter, so you're likely familiar with these benefits already. And then as you all transition into the sort of professional world, they really encourage maintaining that membership, and as it transitions to a young professional membership. And so I think it's free for the first year and has reduced rates for the next couple of years. And so, I found personally that involvement in these professional organizations, ERI being one of them, is one of the things that really makes your your job start to feel a little bit more like a career, and you're not just, working a long week for the sake of the work that you're doing, but you really feel like you're connected sort of into the broader movement of the profession. And so I think that's one of the really valuable things I would encourage everyone as they transition into the professional life to get involved with. Of course, you can go to ERA's website and learn more. And then I guess for me personally, my experience with ERA, I actually wasn't as involved with it. I was more involved with SCAW at the local level here. I live in Seattle, in Washington State, and I applied for the Hausner Fellows Program, which is a 2-year, essentially self-guided project that a number of other multidisciplinary professionals work on together, and they have funding and a whole sort of mechanism for it. Was originally established, I think, in 2013. So we were the third class in 2017. That's a class on the left, and that really afforded the opportunity to get plugged into ERI as an organization, and it was really a powerful experience in molding my career individually as well. And now I'm currently on the Washington Chapter Board of Directors. So that was my sort of required ERI sales pitch intro. So that I'll sort of transition. I know normally when I do talks in person, I really encourage a lot of dialogue, and really I gain a lot off of the feedback and even seeing people's faces and reactions. So it's a little bit more of a one-way monologue for this portion of it, but I look forward to afterwards. But feel free to put some chats in, and if I see it, I can address it as I go. But really, when I presented the idea of just doing an overview of earthquake reconnaissance work, I haven't actually given this sort of combination talk. Each of these earthquakes that I've had listed here that I've had an opportunity to do some research on, I probably have 4 to 8 hour seminars that we gave after those events occurred, and a ton of detail. And so trying to distill that down into a high level is a challenge. So I'll try to cover at least the first couple of these. I've put a couple in brackets because I don't know how much time I'll have to go through it all. So my disclaimer is this is like the sampler platter, the greatest hits platter, if you will, to mix metaphors, and just to kind of reflect on and share some of my experiences in observing these communities and these earthquakes firsthand after them, and then sort of we'll get to Q&A, and I'm sure we have opportunity to sort of dig into a lot more detail. So just to kind of start how I got here, I wasn't always aware of or interested in earthquake engineering, but like many of us in the structural engineering profession, at least, started at an early age, just like building things. I think Legos are probably responsible for like 50% of the engineers in the structural engineering profession. So shout out to them. I also grew up in rural North Idaho, where I had nothing but trees and some lumber from some barn projects that my parents had. So I grew up building forts. I was actually particularly proud of this. I don't know if you can see my cursor, but this thing on the left, there was this rail from my parents' old barn that collapsed in a snow/ice storm, and so I used that rail to build this old roller coaster. It was actually way too steep and pretty dicey and dangerous, but the photo's cool from my I was probably age 12. So I evolved to go into civil engineering in undergrad at University of Idaho, and a structural engineering focus, where whenever the topic of earthquakes came up, it was, we don't talk about that here. You go to the West Coast if you're worried about that. So it was kind of interesting because they essentially, in my recollection at least, punted on anything, post-linear behavior. And so it was kind of a mind-blowing experience where I transitioned to get a master's at the University of Washington, where our entire focus in essentially the context of everything we discuss and we're learning and technical and sort of conceptual level, we're really around earthquakes, dynamics, nonlinear behavior, ductility, et cetera. And so I transitioned there to Reed Middleton, where I've been for about well over a decade, and 12, 13 years. And we're a relatively small employee-owned civil structural engineering firm. We do a lot of seismic upgrade work, as I think the bio illustrated, with 3 offices. If anyone is interested in graduating, looking for a job, feel free to reach out. We're definitely looking for people. So that's really the sort of the evolution of how I got here. And most of these reconnaissance trips have been kind of while I was at Reed Milton. The first one I'll share was actually while I was a master's student at the University of Washington, opportunity to organize a team, through some colleagues. So, maybe the first question might be, why do consulting engineers participate in doing post-earthquake reconnaissance? So there's some generic bullet points here, but one, the engineering profession, in particular, earthquake engineering profession historically has been this experience-based field where a lot of the institutional knowledge that we have is a byproduct of lessons learned lessons learned the hard way after seeing how things failed. And so there's a long sort of lineage of our collective understanding evolving as a result of doing this type of reconnaissance work to study what worked and what didn't, as well as, of course, all the research that supported that and evolved ultimately into the design codes by which we design and build our facilities and structures today. There's a lot of perishable data, immediately after event. And so getting there and observing during this sort of window of time where essentially it's this real world laboratory where rather than all the controlled environment and funding to test the structure, all these structures were just tested. And so, there's just a real tremendous opportunity for learning, and particularly those of us that work in the earthquake engineering field specifically to, endeavor to be experts and thought leaders. It really sort of shapes our understanding. And I know for me personally, if I'm arguing with a contractor about why, the bar has to go in this way or, whatever it is, having seen what happens when those things are not done in accordance to the lessons learned, having seen that firsthand really empowers me, to understand the motivation and sort of hold them to those requirements. And then, really what we intend to do, endeavor to do is, just admitted one to the room, is to disseminate these lessons learned, to the larger profession, to our communities, and to sort of leverage them for efficacy. And so, a lot of our work has been sort of taking these lessons from earthquake reconnaissance home to our local communities and trying to sort of disseminate and leverage them. And, it's really important that this work is done through partnerships, ERI and other organizations. And then we've also participated in sort of post-earthquake response, especially doing ATC 20 building safety evaluations in the affected areas as one sort of really tangible way that while we're learning, we can also be helpful. So those are some of the reasons why we participate in this. So the first one I'll start with is 2008. I was a graduate student at the University of Washington, and this event happened while I was TAing actually the undergrad earthquake engineering class, and the professor who later became my boss at Reed Milton said, "Hey, if you want to do the legwork to organize a team, we can go study it." And that concept had never even actually occurred to me. So I was able to write some letters to the Chinese government and get approval because there's a bunch of logistics to get there. And we were able to send a team of professionals, in the Seattle area as well as myself to go study it. So again, disclaimers, don't have a lot of time to go into a ton of detail, all these events, but it was a really profound experience for me firsthand to see this earthquake and its impacts, in the context of, deep into the weeds of all the sort of technicalities and things that we learn about, specifically in the master's program there. But you can see some of the high level details is in central China, which is, moderately rural, though they still have, relatively large cities. I think they've got a ton of million-plus cities in the country. But the high level takeaway is it was essentially a design level event in that area, if you will, magnitude 8 with some pretty strong violent ground motions. And the byproduct was frankly a pretty extremely tragic event, 87,000 fatalities, over 5,000 people left displaced or homeless, just these mind confounding statistics on the impacts and $400 billion of losses. So there's a couple of just real quick case study examples that are kind of burned in my brain from that experience in 2008 and studying this. One is a school building that we saw, kind of your typical 4-story middle school building, sort of rectangular footprint. It was, a very representative type of building to some of the other schools that they have in this area. Constructed in 2006, it was essentially a brand new school building, and it was constructed with sorry about that. My mouse or something just started going wild on its own. Constructed with confined masonry, which is a system where they build the masonry walls and then they essentially pour in a concrete frame around it, a column and ring beam that confines the masonry. And even though it's unreinforced masonry, it actually has some energy dissipating capacity because of the ways that you can imagine the bricks are forced to sort of rub against each other as it experiences lateral motion. So here's a type of construction they used for this building. You can also see there's some plaster on the surface that was added. And, sorry, my mouse here is really going wild. So, essentially I would characterize as a life safety level of performance. There's some shear cracks in the masonry walls, not unexpected, in these sort of coupling beam sections, if you will, spandrel beams, and the sort of masonry infill, stereotypical X-cracking. All the students got out of the building safely, certainly had some damage and a lot of repair work to be done. Across the street was a nominally identical school building, and this is what it looked like. This was a sort of purely unreinforced masonry building. As you can see, just catastrophic collapse. And this was the case with really a ton of different school buildings throughout the region, and the event happened to happen during school hours, which made it particularly tragic. And so just their new design approach, based on some recent code requirements to confine their masonry, even though on paper the things I was learning at the time would be that this building, the confined masonry building, is still not the best earthquake resistant type of system. These relatively cheap and nominal changes, just had a profound impact on the performance of these two buildings juxtaposed, and this is sort of extrapolated all throughout the region in similar cases. Throughout, this event, there's certainly a number of different cases of poor seismic detailing. You can see the non-confined column here with these really, really spindly confinement ties that really quickly failed and allowed for buckling of the longitudinal rebar. Such a failure of this column is pretty common. Some hospital buildings that had unreinforced masonry infill, which allowed it to certainly be unoccupiable as an essential facility, was a pretty profound takeaway. There's also a lot of buildings that performed well. Here's an example of a hospital that we saw that had essentially little structural damage, but was not occupied, as you can kind of see by the picture of walking through it. And they had hospital tents in the parking lot. And we came to find out that just kind of the nature of a governmental structure, they concluded that they would have to wait for the sort of federal government to come in to tell them it's okay to stay in a hospital. So they set up a temporary hospital facility in the parking lot, even though by our perspective, and granted, we were coming from outside and totally unaware of context, et cetera, it seemed like they had a very usable hospital that was right there that they could have occupied. There's also some pretty dramatic scenarios like this, a lot of lateral spreading and collapse of this bridge here as a result of that lateral spreading. So kind of wrapping up this China earthquake, some of the conclusions, one for me, just personally learning about all these things to really illustrate how real it was. The dynamics in particular was kind of mind-bending. You can see some of the dynamics expressed in the school's library here, and the photo on the bottom left. But seeing smokestacks, these really long period, unreinforced masonry smokestack structures with a long period that were still standing because of the high frequency content, was really just sort of illustrated the things that I was concurrently learning in my master's program. As I try to emphasize the details and the codes matter, and the difference between confined masonry and pure URM is really a profound illustration of that. there's certainly a lot of issues with their construction QC and oversight. Just generally, I think there's a lot of sort of interesting conversations that we had, just seeing the homogeneity of their structures. They had, hundreds if not thousands of the same buildings, and, particularly some of the government buildings like schools that were copy paste. And when that works well, it's great. But when it has issues, it results in this, really large impact, to that categorical type of building, such as schools. And so, we have a lot more differences, heterogeneity in our structures, and to some degree, maybe there's some value in that, because your eggs aren't all in one basket when that basket proves to be not the best. It illustrated some, there's a lot of, million contextual things with respect to sort of the way their government and society is run and expectations. And so it's just sort of interesting to see how their post-earthquake response was organized, in that context relative to how we have seen things done elsewhere, or, would expect in the United States. But ultimately, for me, seeing firsthand how these real earthquake effects impact real communities, really coupled with a sort of technical learning context, really, I think for me, kind of set the stage of my career, and sort of set me on a path of focusing on that, and the ways, the small but powerful ways we have in our engineering professions to sort of have impacts and really mitigate those impacts on communities. So a couple of years later, I was working as a professional, and this other large event, magnitude 8.8 Chile earthquake and tsunami occurred. And this was particularly relevant for us on Pacific Northwest. There hadn't been a large subduction zone event since 1964 in Alaska. And so us in the Northwest are expecting one, as we haven't had ours for the last 321 years. We're really paying a lot of attention. And so, just see the three large metropolitan areas of the Northwest juxtaposed to Concepcion, Chile. And, it's different language, different content, but things really are very similar and applicable, which is a lot of our motivation to go study it. And the thing that's really important to emphasize is the large geographic area that these subduction zones impact. You can see some of the areas that we visited, span, at least the MMI, modified Mercalli intensity scale of a very strong event, or higher, impacting a 400-mile range or larger, is just pretty substantial. And then also the large amount of substantial aftershocks depicted in the right. You can see the magnitude depicted by the diameter of the circle, and there's, magnitude 6s and 7s galore in the weeks and months that ensued following the first magnitude 8.8 shock. So the first sort of what we arrived to come to understand is this is the Santiago airport upon arrival. This is maybe 10 to 14 days after the main event. And this is, 300 miles from the epicenter, if you will, of the event, and really the main entrance port to the country. And it's being operated out of a series of temporary tent structures. Here's the walkway that had collapsed entering to the main airport facility. Here's the check-in areas that have really just remarkable non-structural damage, including large pieces of HVAC equipment like this one, obviously inadequately anchored and falling through the ceiling, which is just like a nightmare scenario and pretty egregious. So obviously this airport was occupiable, and so as a result, this really essential facility, especially for all the resources coming to the country and to the region to provide support, were now being operated out of this temporary facility. Incidentally enough, I had a chance to go back 7 years later, for the World Earthquake Conference, and this is what that same space looked like when it was occupied. So that was in Santiago. There's a whole bunch more damage in Santiago that we have observed, but we'll take you quickly to Concepcion, Chile. And there's a couple of really notable collapses that occurred that you may have seen on the news. And they really illustrate a main concept of some of their building codes that were eliminated that contribute to those collapses. But the thing that was really profound is that those collapses were in relatively new buildings. This is a 2010 event, and essentially a brand new condo building, 20-story, or it says office, I think it's actually a condo building. And that's what it looked like afterwards. In the bottom of your photos is the roof. Is essentially the whole thing, for lack of a better term, broke off its foundation. And here in the left, these are the urban search and rescue, essentially holes that were created as those rescuers attempted to extricate victims. And we actually did hear, it was relatively unoccupied, fortunately, because it's so new. But we did hear some anecdotal stories of people who had survived that collapse, which is, again, sort of a nightmarish scenario. Here's a sort of elevation view of this building, and really the byproduct of inadequate tension anchorage, as well as compression boundary zones. Really, the columns embedded into these shear walls that didn't exist and allowed for this catastrophic form of collapse. You may have seen on the news, if you're paying attention after that event, some other sort of iconic failures. Here's another brand new office building. I think that's what the previous text was intending to be related to, that had essentially inner story collapse at this vertical setback, which is not uncommon at these setbacks to have this type of failure as a result of sort of the dynamics and the concentration of forces. We also spoke to some people who, again, this is anecdotal, that said that the tenant improvement projects of the occupant on that floor had removed some shear walls. I don't know if that's the case, but that's what we were told. And you can see, the inner story collapse, obviously red tagged the unsafe occupied building. I did have dreams about being in an earthquake after some of these events, and you can see this sort of standard office chairs that were kind of holding on by a thread, and just like you can imagine. Fortunately, this event happened to be about 3 a.m, so office spaces were not occupied. But just the experience of that is hard to wrap your head around. But I used to have like the most nerdy dreams where I was dreaming that I was in an event, and then I was imagining like the nonlinear behavior, the reinforcement, like, oh crap, it's buckling now, and I was like seeing the hysteresis loop while I was in it, which I'm sure is what you all dream about, but perhaps not everyone. But incidentally, even in such a extreme scenario as this building wasn't totally required to be demoed, and they're actually able to repair it. This is what the building looked like on the left about 7 years later. They've changed the sort of architectural look of it, presumably to sort of disconnect from all the news stories of this building. One more high-rise building, and really just because this has some interior photos to illustrate what I mentioned earlier. Again, almost brand new building, concrete shear wall system, and essentially total failure, shear failure here of this wall. And then see how remarkably slender the shear wall is, particularly for a high-rise building like that. And then again, the lack of confinement reinforcement and a boundary zone, essentially the column at the end of that wall, you would anticipate to see here. And essentially what we learned is their code was essentially modeled after our previous iteration of the IBC, I think actually UBC at that point. And it was nominally identical, except the one boundary zone requirement that we had, for some reason, presumably political reasons, had been removed from the code. And so that one piece of code resulted in scenarios like this or the previous collapses. Make sure I'm good on time. I have this audacious goal of covering all these events around the world. So here's a hospital building that we saw in Concepcion as well, and structurally performed reasonably okay as far as we could tell, just from trying to study it. But we were told by the chief surgeon that they had a major water pipe break in the upper floors of the building. That water cascaded, and the ORs that were in this wing of the building were no longer operational, pun intended there. I didn't intend, but no longer operational. So here's some equipment that they moved in that sky bridge. And, they really had to relocate a lot of these really critical, especially critical activities, medical care providing activities to other areas of the building as a result of really the non-structural damage, which really, is not a new lesson, but a corroboration of the reminder that, in order for these essential facilities to be usable, the structure has to perform well as all the supporting mechanical, electrical, plumbing, architectural systems. And, that water pipe failure resulted in them storing equipment here and moving their operations elsewhere. And again, coming back 7 years later, there's what this, I believe, new wing of the hospital looks like with supplemental sites and campers. There's a number of other sort of not unexpected building impacts. Here is essentially a Lowe's or Home Depot type of building, concrete tilt-up building where the heavy concrete walls pulled away out of plane from the roof supports, which was a lesson that we learned here in the early 90s about some of our detailing and cross-grain bending that we are still working on retrofitting a number of those type of buildings, especially here in the Northwest. So really illustration of proactively getting at that issue of connecting our tilt-up wall, heavy tilt-up concrete walls to our roof diaphragms more adequately. Of course, unreinforced masonry, I think this actually happens to be a adobe masonry structure, vulnerable building type, or impacted severely, as well as with the sort of geography of the area. There's a number of really critical bridges to get across, which, me living in Seattle, we have a kind of analogous scenario with some of our bridges. And you can see the catastrophic, failure of some of these bridge spans. Incidentally, as we were kind of ended this bridge a decade ago now, we're intending to, or considered going out on the bridge to see more specifically what that failure looked like in the connections, but we elected not to, which is better judgment, as there was a large aftershock while we were there, and some of these spans dropped, whereas we could have previously walked out all the way out there. So it was definitely a lesson reminded, regarding just safety and just being smart, not geeking out too much on the technical impacts. There's a temporary sort of soldier bridge was put up after this collapse span of a pre-stressed girder bridge, and also some road failures. And so there's some really significant impacts to their transportation system in these major corridors, as you can see. So for the chill earthquake, the last sort of topic I'll cover here is the area of Constitucion over on the coastline. And really, prior to this event, there hadn't been a major tsunami in sort of a similarly type of sort of highly developed area. Of course, Japan happened a year later, but so we're really interested in that, especially for us that are expecting that in the Pacific Northwest region, from Oregon to Vancouver, BC. So here's one of the port areas, and you see all the containers that were essentially strewn about after their inundation zone impacted this sort of whole port region of the area. Walking around is not uncommon to just turn the corner, run a street, and see a large boat like this one just sitting in the middle of the ground that floated its way in, which is, just feels like you can't believe your eyes when you see something like that. And, a lot of the really vulnerable communities that had sort of single family housing really adjacent to the water in the inundation zone, either had their house entirely swept off its foundations as depicted by the footprint here, or just so severely impacted that there was sort of damage beyond repair. Here's examples of all the debris that gets dumped into, this is a first story apartment building. It gets dumped in these spaces, and it's pretty nasty if you think of all the different types of biohazards and chemical hazards and contents that they get sort of caught up into that inundation and then dumped in these spaces. And so it's far from being an occupiable space. The areas that did perform, or I guess were in better shape, were structures that had a concrete moment frame on the first floor and then wood frame above. For this event, the inundation was around 7 or 8 feet. And so this happened to be like an area where you'd rent, like kayaks and things of that sort, and ended up being really a community resource as all the sort of foods and effects that were distributed after that event were utilizing this facility that had that type of structure. And again, sure enough, coming back 7 years later, a lot of the homes in this community were constructed with a similar type of approach where there's this concrete moment frame, and essentially the whole first floor was either like a garage type space or had walls designed to be sort of blowout walls in case a similar event occurred before, that people could have an occupiable second floor, which is sort of really interesting to see those lessons being applied in new construction so quickly. Also, here's a municipal building area nearby, where essentially in constructing this 2013 municipal building for the local municipality, they ended up creating this access to the roof with the intent of being a community accessible vertical evacuation structures. You can see these ramps and stairs that allow you to get to the roof of this building with just a giant footprint about 3 stories above to allow for vertical evacuation. So some of the lessons learned from this event, certainly that boundary zone detail was really critical. And I think the counterintuitive thing was that it was really a number of the newer buildings that had suffered those catastrophic failures, and that as a result of a number of things, but as they began to sort of push the bounds in terms of their architecture, and the proportion that a lot of research has subsequently done on the proportion of shear wall area to footprint of building area slowly decreased over time. And so the newer structures end up being the most vulnerable. And I'll say the examples I cited were the extreme cases, and there's thousands, if not tens or hundreds of thousands of buildings of a spectrum of age and type that weren't as impacted. And so really just showing you a snippet of the worst, which is important to keep in context in mind. As you saw the airport, designing those from a structural standpoint for immediate occupancy, and really in order for the facility to be operational is ensuring that the non-structural systems are adequately designed to accommodate movement and not break, as illustrated by the airport as well as the hospital in a number of ways, aside from these really catastrophic scenarios that I exampled. A lot of U.S. codes in a number of ways are really validated from this magnitude 8.8 event performing pretty well, aside from that boundary zone issue. There's a lot of retrofits that have been done. They get earthquakes really frequently here in Chile, in that part of the world. And so they're no stranger to it, and they're probably a lot faster than us as a result of that. Proactively upgrading some of their facilities. There's certainly some transportation system redundancy things related to the bridges and the roads that I illustrated. And certainly for us in the Northwest, Pacific Northwest, the tsunami risk in some of our communities there, and realizing that horizontal evacuation is usually not an option as roads get clogged up and people get in cars and they can't go anywhere. And so localized vertical evacuation structures that are accessible by foot to all members of the community is really the next step that we're working on. And the last couple of years, we've had a couple of schools designed in our coastal areas accordingly. Oh yeah, here's a poster I saw while I was there, where this lady is really emphasizing the importance of immediate occupancy. I think that's what the point of the advertisement was. I'm not sure. So similar, a year later, this large magnitude 9 event occurred in Japan, called the Great Japan Earthquake, as you probably recall in the news. And a very large area was impacted both from the ground motion as well as the tsunami. I won't go into a ton of detail, but Japan's probably number one in the world in terms of their earthquake preparedness. They're much more active at installing innovative systems like damping systems, base isolation. And so not all buildings performed well, certainly, but just as a general statement, it was pretty encouraging to see the level of performance of their structures from the ground motion. And here's some examples of toggle configurations of fluid viscous dampers being installed in a municipal building in Sendai. Base isolation is much more commonly applied. You can see in this corporation building here of time, but this video is pretty cool to see the differential movement of essentially the building staying still while the ground is moving relative to it. And so really the big takeaway from that event was just the unprecedented magnitude of the tsunami inundation and run up. And, your eyes aren't failing you. These are magnitudes of meters of the height of the run up in these different areas, which is pretty hard to prepare for. And so there's some communities like this one, which is arguably one of the best prepared communities in the world, and moved some of their schools and port facilities up the hillside. They have this sort of tsunami preparedness wall. They have signs all over from how high the tsunami was previously. And it just turned out that their tsunami in this area was much, much larger than certainly that they'd experienced in the past, or that they had really anticipated. And so this whole community, for lack of a better term, was almost swept away. You can see some depictions of that tsunami barrier wall that was installed. I think previously they had a roughly 6 or 8 foot tsunami from some previous events. And so they ended up sort of brings up an interesting question of what factor of safety do you apply on that. So I think they ended up, multiplying by 2 and rounding it, ended up being 8 meters or something like that. And then this area, they had order of magnitude 30 meters of inundation, which is essentially impossible to prepare for other than relocating the town up the hillside. Is really the only thing you could do, which is a hard thing to do. One story that we learned was this is the Disaster Preparedness Center that was designed to have people vertically evacuate to the roof of the facility, as depicted by this greeny picture during the event. And they did so, and the waters rose that elevation. And there's a lot of interesting cultural things. I don't have time for the whole story, but they told their mayor to get on sort of the roof of this telecom tower, on the top of this telecom tower, to protect themselves, which I think if our politicians did that, it wouldn't look so good. But just kind of cultural context of forms of respect, it was interesting to hear them tell the story. Fortunately, he and a number of people survived. Unfortunately, obviously, many people, I think order of magnitude 10,000, didn't from the tsunami. But this is that structure afterwards. So a lot more I could go into, but Japan, generally speaking, is one of the most prepared nations in the world, and their preparedness saved lives. And even this magnitude 9 event, which seems, you hear people talk about the big one out here, and they act like it's not something we can prepare for, but they actually, in terms of the structures, preparedness for the ground motion, generally performed relatively well. And a lot of their proactiveness in implementing these seismic protection systems really paid off. And because they get ground motion so often, the public demand a higher level of protection, and in general are willing to pay for it. We've seen examples of, the cheap hotel here that says we have HBO, we have free Wi-Fi or whatever. They'll have hotels that say we have a base isolated building, and people pay, $7 more for that hotel night, just knowing that they have that level of protection. So, I think as a result of the frequency and magnitude of what they've experienced as a community, it has been sort of incorporated into the society and culture in really impactful ways, in the ways that they demand it. And then certainly vertical evacuation structures for tsunamis, they have to be tall enough, well designed, they have to be locally accessible without requiring people to get in a car. That's something that we're trying to learn from. See, I'm doing time. All right. I'll go through the Central Mexico earthquake 2017. The main context of Mexico City, if you weren't aware, is built on a historic lake by the Aztecs in I think 1300s. I removed that slide. And so subsequently they drained the city in the 60s. they drained it over generations, but especially in the 60s, and undertook this major project is on this historic lake bed, and that really illustrated itself in the impacts. But if you go there today, it's a relatively modern city with buildings that look like this that were essentially undamaged. Also a historic city with areas that look like this. This is a couple weeks afterwards. And a lot of that was because they had this major event on September 19th in 1985, where the dynamic frequency of that historic lake bed impacted a certain type of building, certain building height, but it equally importantly impacted sort of society in the way that they prepared. And so they have an annual drill every year on September 19th. 32 years later, coincidentally enough, September 19th, after they've had their morning drills, they have this magnitude 7 event, roughly 75 miles from Mexico City, as well as these other towns that I don't have a ton of time to go into today. And, they had a couple of pretty significant collapses, 38 collapsed buildings, 2,000 damaged buildings. But that's in the context of a large metropolitan area of 25 million people, give or take. You can see some of the specifics here, but the really kind of interesting, remarkable thing is you don't know where the historic lake bed is when you're there. You're just driving down a busy street, but when you start overlaying where the historic lake bed was from when the Aztecs showed up relative to the impacted areas, and there's all sort of on the boundary of this lake, there's almost like if you imagine a bowl or a bathtub full of Jell-O. If that Jell-O is sort of shaking back and forth, once it hits the sort of rigid boundary of the bathtub, that's sort of where these sort of amplifications occurred, and that's really where a lot of the damage was concentrated. So you probably saw in the news some of these really catastrophic scenarios, like these couple apartment and commercial buildings that collapsed. There's a lot more buildings that looked more like this that were unoccupied, but displaced people. So if they didn't have family to move and live with, there's a huge issue of where do these people live now, and then how long does it take to repair and get these buildings occupiable again for apartment buildings and the commercial buildings and all the sort of business interruptions and sort of societal interruptions and costs that ensued from these examples. But I think the main thing to take away is that's a relatively small percentage of buildings that were impacted in this very large, expansive metropolitan area that makes flying over LA look like a medium-sized town. So a couple of takeaways from Mexico City: lake bed effects were significant. There's a whole number of impacts to the water system and who that disproportionately impacted as a result of the more than 1 foot of settling that often occurs in a typical year in the area. So there's a whole presentation we have on water utilities is something that we've been learning about, but really it was a localized damage. But what we had an opportunity to sort of partner with and learn about was a lot of community organizing, doing HC20 inspections, the local CICM, the organization of the College of Civil Engineers, essentially, and a number of the students that we met were taking really impressive leadership roles in organizing these post-earthquake safety evaluation efforts. And there's millions of other examples of community organizing that we observed that was pretty remarkable. And I think it's probably a worthwhile example to look into of like what real world resilience looks like. They had this major event 32 years prior, which was much, much more impactful in 1985. And, a lot of the city, you might not even know there's an earthquake. Certainly there's major impacts and impacted individuals, tragically and profoundly. But overall, it was actually pretty impressive to see how all the work they'd done investing in retrofits over the last 3 decades, as well as technologies. They had a national early warning system that allowed a number of people to egress into the common spaces. There's a number of videos online. You can see people standing in the middle of squares when the ground motion was occurring. Public awareness and and whatnot. So there's a lot of positive takeaways from that as well. For the sake of time, I'm not going to go into a ton of detail, or I won't really cover this, but our company does a lot of work with the federal government and the Navy particularly, and so we had a heavy role in doing building safety assessments and damage assessments after an earthquake series 2 summers ago, a 6.4 and 7.1 event that essentially happened on the 4th of July weekend in Central California, but really was concentrated on this large military base that is, the base itself is the site of Rhode Island. So a lot of, I guess, the media didn't probably cover as much as another large earthquake that would have occurred in the United States. But they had some pretty significant impacts to some of their hangar buildings, et cetera. And I think, multi-billion dollars of losses from this military installation, and really are still in the process of, there's initial response phase of sort of responding to the event, damage assessments we assisted with, and there's a recovery phase, and now they're sort of figuring out and executing repair and seismic upgrade projects. So I think I only have a couple minutes left. So the last thing I want to share about was some work that our housing group I alluded to did with this idea of resilience reconnaissance. And, a lot of the traditional, quote unquote, traditional reconnaissance has been, understanding how facilities, buildings, structures are impacted from a technical standpoint. And, frankly, I think a lot of those lessons have been learned over the last generation or so and have been embedded into our seismic design code. And so we know unreinforced masonry buildings are vulnerable. Studying that again is impactful, profound from an individual standpoint, and really empowers new generations of engineers on the reason why we do what we do. But in terms of technical learnings, a lot of those lessons have been learned. And so, the vision is to evolve this idea of reconnaissance into trying to understand resilience, which is super complex and hard to wrap our heads around, and hard to measure as well. And, in part because it occurs over time. So there's this sort of temporal aspect. And so you have to understand the before the event, why things are the way they are, how they got to be that way, what happened, and how they evolved to really have any sense of what the resilience of a community is. And so our housing program endeavored in putting together sort of a framework for people doing resilience reconnaissance to do so, and understanding the climate beforehand, social, political, physical context of a space, and develop storylines that sort of encompass these various sort of multifaceted dynamics, and in order to really for the goal of understanding what makes communities resilient or not. And oftentimes, it's the human infrastructure rather than the physical that plays the most critical role. And so, we have a whole bunch of tools, and there's certainly a lot of recent presentations. If you haven't seen David Bonavitz's presentation on functional recovery and community resilience, which gets into this in much more detail, I encourage you to check that out. But, really the intersection between the human environment, the systems that we create as society, the built environment, and natural environment. And so in order to develop these storylines, this progression of understanding pre-event context, the event occurs, what are the immediate consequences, which is really what I've been focusing on, for the last 45 minutes or so from these various events. But there's these cascading impacts where, the human natural environments intersect the immediate consequences of the built environment that, creates transformation for better, sometimes for worse. And so some of the tools that we came up with for conducting resilience reconnaissance in this sort of framework, one is, development of a context packet. If you're not familiar with the virtual earthquake reconnaissance team, it's really a way for anyone to be involved with doing this type of reconnaissance work just by doing online research and compiling information in real time. ERI has a team of people that mobilize. A lot of them are younger students or younger members. And so if you're interested, I encourage you to check that out. Reach out if you have any questions. But our idea is to allow that VERT team to prepare this context packet. So anyone that is conducting in-person reconnaissance work can do so with physical, social, political context in mind. Mindful of time, I'll wrap up here in a second here. we came up with this primer, sort of a set of slides that really introduce these complex concepts of, what resilience is, how to look for it, and then these reference cards for, and having conversations in the field, how to develop the storylines. And so we had the opportunity to do so in this small town called Huhutla. And I won't go through the details right now, but it was pretty impacted in this town of 70,000 people. And we saw, communities coming in and sort of that intersecting with the political context, and came up with this whole storyline where sort of the politics, the sort of infrastructure of actually how they organize their land titles, as well as the events and outside organizations come in, all intersecting in this sense of the storyline. And so just to wrap up here, since I think I'm at the end of my time, reflecting on, my first third to quarter worth of career and seeing these earthquakes in real life sort of juxtaposed to my real day-to-day life of actually designing retrofit buildings, studying them, et cetera, as we do as consulting engineers. One, it's really the emphasis that the work that we all do as a profession really matters, and the detail that we work on and spend so much of our schooling time learning about, and our careers working on enforcing really matters. And these lessons from these events really have historically shaped the profession, shaped the codes, our understanding of performance, from structural systems to now, evolving into the discussions of functional recovery and resilience, and also impacts careers such as my own, and the way my whole understanding things has been informed by these firsthand observations. And it's really easy to kind of geek out and get sucked into that aspect of things, but we can't decouple that from these communities that are really impacted. And so, as we talk about resilience, reconnaissance, one of the things we really focused on emphasizing with our housing group was, how do we do this work in a way that has reciprocal benefits to those impacted communities through partnerships with people on the ground. And I didn't get a chance to share a bunch of those stories, but those equally powerful is meeting local students, people volunteering, coming from other states to do post-earthquake safety assessments. And so I think in doing this type of work, it's really important to partner with people, and it's not a one-way sort of taking, but an exchange of experience and time to allow for those reciprocal benefits. And I think I made the case for evolving from sort of a focus on just technical performance to thinking about community resilience and how to identify that, even if it's a little bit more squishy and less specific and measurable. So my final thought I'll leave you with is seeing all these events, the thing I like to remind myself is, it seems like this daunting, unsolvable problem, but it's really a man-made problem. If you think about it, if we didn't build any man-made infrastructure and you're lying in a field, earthquake occurs, then you're just lying on the ground getting a massage from the earth. You know what I mean? So it's really because of what we built that makes it a problem. And because it's a man-made problem, that means there's opportunity for man-made. And by man, I mean human, of course, human-made solutions. And so I think that's what I find encouraging, as well as making a more safer, resilient world for next generations. So I had to show my new 12-week-old son Kai here, who, if nothing else, I thought I'd close with that because he's adorable. So anyway, thanks for letting me go a couple of minutes over here, and I'm super excited to chat with you all, and more than happy to take questions now. And also, I have my email here. If anyone wants to reach out and email me, I'd also give my phone number. If you're interested, I'd be more than happy to talk with folks. And also, if you're interested in jobs, reach out to me as well. But just in terms of career advice or any of that stuff, be happy to share what my experiences were. This presentation is really a small sector of reconnaissance, which is not really the day-to-day work that I do, but hopefully interesting nonetheless. So with that, I'll turn it back over to either Katerina or others.
Thank you, Erik, so much. That was a great presentation, like full of pictures and, you know, failures, different kinds of failures and structures. So I have let's open the floor for questions, and I'll save mine for last. So is there anyone that wants to ask a question? Since we're a small group, I guess, Ahmed, we can like give directly the access to people and they can ask their own question. There's no.
Yeah, exactly. You can just unmute yourself and go ahead and ask Erik directly.
So are there any questions?
I can ask a question. It's me, Katerina.
Sure, yeah.
Thank you so much for your great presentation. We are coming from a very strong earthquake engineering educational background. I'm from Greece personally, so I've seen a lot of these pictures over these years, and I'm really interested in this type of reconnaissance efforts. My question is, it's a general question based on your experience, because you did a lot of trips in a lot of places, and I would just to ask your opinion about something. When you see a failure in all these places that you saw, can you say to us if these failures are coming mostly from the poor quality in the construction, or they're coming from inadequacies in the local seismic code that they're using, or sometimes they're coming from some decisions in their design process, such as maybe big irregularities in height or in the floor plan, or some other questionable decisions about the shape of the floor plan. Based on your experience, which is the most critical factor in these failures?
Yeah, that's an interesting and a tough question to answer, because obviously, to some degree, it's all of the above. So in order to state one or the other is challenging. You know, I think the thing I've learned more and more is it's to really get at the answer for each event is it's largely contextual. And there's usually a reason why things are the way they are, be it from, you know, like you said, codes that evolved or had elements of them removed, like I explained in Chile, to, you know, a reference, you know, poor construction. We saw scenarios where there was, you know, empty paint cans put into concrete walls to reduce, you know, contractors trying to save on on concrete volume. Certainly those things, when those scenarios come up, are big contributors. And so my disclaimer, I guess, is largely contextual. I think the thing that well, I guess two thoughts. You know, one, I'm sort of guilty of this myself, and this whole presentation is really focused on what didn't work. But, you know, we as a community probably need to continue having more emphasis on what works. And so I think now, when I've, in more recent years, seen events, I've been more interested in showing what did work, even though it doesn't show up very well in you know, a presentation, because it's just, hey, here's a building. But, you know, like looking at Mexico City, for example, there are like tens, if not hundreds of thousands of like literally copy paste same building, even in the same zones, you know, across the street from each other, that, you know, one was severely impacted and the other, you wouldn't have known there's an event. And so it really illustrates, you know, in addition to things that you spoke about before, you know, one, the sort of the unique dynamics of structures. And, you know, oftentimes it was even structures that theoretically aren't going to be great, like a poorly detailed concrete building or masonry building. It's when that is coupled with either sort of resonant frequencies or irregularities, big, you know, goofy openings or setbacks, you know, vertical or horizontal setbacks, things like that, where the most sort of catastrophic things occur. And, you know, even these theoretically poor buildings, even with probably not the best construction, you know, when they're more regular, they don't have those large openings or kind of goofy things that require a transfer of force and also have peculiar sort of dynamic responses associated with them. Crappy buildings, for lack of a better term, often do well. You know, we see the handful of buildings that don't, But for any one of those, there's 10, if not 100 of like the identical building that was not impacted for a variety of reasons. Also kind of illustrates just sort of the probabilistic nature of, we talk about collapse percent, and, the building code, I think, states that a goal of like less than 1% collapse. And I think all these places probably have less than 1%. So, maybe that goal needs to be adjusted accordingly. But I don't know if that rambling really addressed your question, but there's some thoughts at least.
Well, thank you.
So mine was a little bit related. So now that Dimitri stole my question, I have another one. Yeah, it was mostly related about the construction and how, applying code or a standard might, end up in a poor result because of the way you're constructing something, not just the way the standard is made itself. Like. I wanted also to ask whether during your reconnaissance, you also asked as a professional, having a professional opinion, whether some of the buildings are able to be like reinforced and get back on with the way they are, or if you, suggest some more solutions at the secondary stage, not when you're going through them and you decide whether they are of their condition. But I was wondering whether there is some kind of suggestions you formally make as international sometimes observers in terms of, you could probably, reinforce this, or you should probably tear it down. There's no way you can fix it or something like that.
Yeah. Well, I guess I'll have two separate sort of categories of, I think, like discussion there. One just in terms of the code, the materials, coming from a certain experience and mindset where like buildings have to be constructed a certain way. These are, we have the benefit of all the material at our disposal here in the U.S. at least. Granted, they're expensive, but it's easy to say you should do this, you should do that, and certainly from a technical standpoint, there's better and worse and ideal ways to do it. But finding the confluence of local materials, local sort of crafts and construction techniques, and sort of the institutional knowledge from that sort of optimizes performance, relative to those materials. So even the confined masonry example is a great use of relatively minimal steel rebar, some frankly relatively poor quality concrete, but confining unreinforced masonry has a tremendous impact. Now, would I recommend anyone design, especially if I was doing design, unreinforced masonry building with the number 4 bars confining it? Of course not. But in that context, like that small sort of increase has a profound impact. So I think in terms of recommendations, of course, World Bank and all these organizations, done a lot of work in this area and trying to develop really simple, even illustrated ways of building that sort of advise local contractors, people adding a second floor into their home, how they can do that more safely. With respect to sort of formal professional advice, we get ourselves in a really challenging scenario doing reconnaissance, because inevitably, especially you're walking down the street, people see you're wearing a hard hat, and they want to know, is my building okay? And more than half the time, it's just like crack in the gypsum. And so in those scenarios, we, if nothing else, just from almost like a counseling standpoint, try to if we can with the time, there's always this balance of a limited time window as well, but try to just help, if nothing else, sort of comfort people and saying, you're just because you have a crack in the drywall, your building's not about to collapse. Or if it is, usually they're intuitive enough to get out of there, but there's some areas where it's like, hey, you might want to talk to someone professional, and in our opinion, this doesn't look like a great space to be in right now. In terms of more sort of formal guidance, like actually making recommendations, that's something just from a a liability standpoint, we try to steer clear of, as well as, not really knowing the context would be often inappropriate. So the scenarios where we've sort of, in some degrees, participated that would be if we are, like in China, we partnered with Sichuan University and had this sort of more formal exchange of recommendations, ideas in that capacity, to empower locals or even Mexico City, like local engineers with some tools and thoughts that we have. So rather than providing them directly, frankly, from a liability standpoint, if nothing else. So probably the most formal thing that we did is ATC 20, if you're familiar with that, which is tagging buildings red, yellow, green, whether or not they're safe or not to occupy. We have assisted with conducting those assessments. And even that is usually in partnership. It's always in partnership with local municipalities, authorities having jurisdiction, and organizations on the ground. So.
Thank you.